All right, so today we're going to talk about all three forms of a quadratic function. So our goal is to be able to convert quadratics into equivalent forms and recognizing those forms and doing a little graphing in those forms. So we have three different forms that we're going to be looking at. There's standard form, vertex form, and intercept form. Now, all three of these forms have their pros and they have their cons. So like why we like that form and then like, but we don't have this in that form. So when talking about these forms and what we can and cannot, what the pros and cons of them, we're going to be talking about the x-intercept, the y-intercepts, and the vertex. So first off, we have standard form. The pro of the standard form, when it's in the form y equals ax squared plus bx plus c, or another, it's also called expanded form, is that you can easily see the y-intercept. So our pro here is that you can easily identify the y-intercept, because if you plug in 0 for x, you get c for y, right? If I plug in 0 here and here, those cancel, you get c for y. So it's just 0 comma c. So that's the pro of it. The cons is that you have to do work, I should say, to get your vertex. To get your vertex, you have to use x equals the opposite of b over 2 times a to get your axis of symmetry. And then you take that value, put it here, and then you do f of that value. So f of opposite of b over 2 times a to get the y value. So basically just plug it back in, okay? So obviously that requires a little bit of work. It's not difficult, and then the other con is that you have to do work to get your x-intercepts. You have to set the function equal to 0 and solve to get your x-intercepts. So set the function equal to 0, and then you'll have your x-intercepts. And remember, x-intercepts are ordered pair points. Okay. All right, for vertex form, the pro is that, hey, you get your vertex. That's why it's called vertex form. Your vertex is the ordered pair h comma k. So if you look, this is a minus h here, so you take the opposite of that value that you see with your eyes, and then k. The cons are that you have to do work to get your y-intercept, and you have to do work to get your x-intercept. For your y-intercept, plug in 0 for x and see what you get for y. So find f of 0. And then for your x-intercepts, just like the one before, you have to set your function equal to 0 and solve. All right? And these all say y equals, but I'm looking at it as f of x equals because we're used to function notation. All right, lastly, we have intercept form. So intercept form is also known as factored form. This is the result of factoring, so it's also called factored form. Okay, and the pros are that you can see your x-intercepts. You set each factor equal to 0 and solve, right? So you get your x-intercepts quite easily. But the cons are that you have to do work to get your y-intercept and your vertex. So your y-intercept, you set the function equal to 0 and solve. Oh, sorry, your y-intercept, my bad, that's for x-intercepts. Your y-intercept, you plug in 0 for x. And then your vertex, you're going to add the x-intercept x values. So you're going to do r1 plus r2 divided by 2. That'll give you the x value, and then you plug that in to get the y value. F of r sub 1 plus r sub 2 divided by 2. All right? All right, so, and let's write over here that your x-intercepts would be r1 comma 0, r2 comma 0. So you set this equal to 0 and solve this equal to 0 and solve, right? Okay, so what we're gonna do here is we are going to graph these functions. I might be jumping around on like, oh, we should find this next and this next based on like the practice required. Like, oh, I want you to make sure you're practicing this concept. Okay, so our first example here, this is standard form. Okay, and I'm just writing standard form. It doesn't ask me what form it's in, but it's good practice, right? It's standard form, and we want to put it in intercept form and vertex form. So that's one of our goals for today, is our goal that's written there. But then also finding our vertex, axis of symmetry, x-intercepts, y-intercepts, everything. Okay, so let's go ahead and put it in intercept form. In order to put this in intercept form, remember intercept form is just factored form, so it has to be factored. Okay, so We have f of x equals, and then we're looking for two numbers that multiply to give us -3 and add to give us 2, which is -3 and 1. So that's x minus 3 times x, I don't like that parentheses, times x plus 1. So that's factored form. And then we also want to get it in vertex form. So to get it in vertex form, okay, vertex form looks like this. Notice it has a binomial squared in it, so we are going to have to complete the square in order to get the vertex. Now we already know how to, or to get vertex form. Now we already know how to complete the square, and it's not the only way to do it. So I'm gonna show you two ways, okay? But completing the square is going to give us that binomial squared. It's not the exact same steps because we're not solving for x, but they're very similar, okay? So what you're gonna do is you're gonna take the function that we have up here, your standard form, f of x equals, and then to complete the square, remember you're completing the square for your x squared term and your x term, right? And you're coming up with this value right here. So the question is what do we do with that -3? Now, I could say I'm going to add 3 to both sides, but then I have to remember to bring it back over because it'll just be over there for a second. So if we want to do it that way, it's fine. Another way of doing it is just moving it over and getting it out of the way, right? So just moving it over and getting it out of the way and realizing that you're not completing the square for that value, and just have it floating over there basically. Okay, so now I'm going to complete the square for x, take half of b, b is -2, half of that is -1, and square it. That is the number 1, so what I'm going to do is I'm going to put a +1 here. Now, if I was solving by completing the square, I'd add 1 to the other side also, okay? But I don't want to put anything over there. So instead of adding 1 to that side, I'm going to subtract 1 from this side to balance it out because 1 and -1 is 0. So now I've done nothing to this side technically. This will always be factorable. So we have f of x equals, this factors to x minus 1 quantity squared. Remember, if you wrote this down, it's just x, whatever that number, it's quantity squared, and then combine these two, which is -4. So there's your vertex form, f of x equals x, I don't want to rewrite it again, but I'm doing it anyways, x minus 1 quantity squared minus 4, okay? Now, if I lost you because I didn't add 3 to both sides, I want to show you that you can do it that way. So if you did f of x equals x squared minus 2x, leave a space to complete the square, and then add 3 to both sides to get to, you know, so you can complete the square. So if I did +3 here, right, I could complete the square, which is with a 1, and then I have to do that to the other side. And so now I have f of x plus 4 is equal to x minus 1, my bad, quantity squared, and then subtract 4 from both sides to get f of x by itself. So -4 minus 4, you do end up with this. So if it makes you feel better to do that, that's fine, okay? There's a third way of getting this answer also. I'm about to show you the third way. So we have to graph this, and we need to find the vertex. The vertex is obviously 1, -4, right? So it's opposite of this, okay? But what we could have done is we could have skipped doing this, okay? I'm gonna skip doing this, put it off to the side real quick. And we could have said, look at the standard form. I wanna do the opposite of b over 2 times a to get the x value of the vertex. So I can do x equals the opposite of the b value, which is 2, over 2 times a, which is 1, and that gives me 1, right there. Then I can get the y value of the vertex by plugging 1 into my original equation right here. So I can do f of 1. So I got 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3, which is -4 right here. And then I could say, all right, I can use this to write my vertex form. Y equals x minus 1 quantity squared minus 4. Okay, so there's so many ways you can do this. And I know maybe teaching you more than one way can be harmful rather than helpful sometimes. I don't know why I erased that. It can be harmful rather than helpful sometimes, but I just don't want you to think there's only one way to do this. All right, the axis of symmetry is always x equals the x value of your vertex. So x equals 1. Your x-intercepts you get by setting your function equal to 0 and solve. The easiest one to set equal to 0 and solve is this one. I get x equals 3, so if I do x minus 3 equals 0, x plus 1 equals 0. I get x equals 3 and x equals negative 1. So my x-intercepts are 3, 0, and negative 1, 0. My y-intercept, standard form is the easiest place to get that. So it's just the c value, y equals negative 3. So noticing having all three forms makes life easier, right? Having all three forms makes life easier. But sometimes it's not possible to go from one form to the other, or it's way too complicated. So we just have to work with that one form, okay? All right, so let's graph this. So let's start with the vertex, okay? So the vertex was 1, negative 4. There she is, okay? Then we can draw on our axis of symmetry. The axis of symmetry is not part of the graph. It's a dashed line. I'm gonna do it in a different color. A dashed line going through that vertex. Okay. Now, we also need other points to make this parabola, right? So the other points that we have are 3, 0, and negative 1, 0. And notice those are symmetric. There's 1 on each side. But then we should also plug in 2 to see what we get, and plug in 0 to see what we get. If we plug in 0, we get negative 3, which we already did. And then it has a reflective point right here, right? Because it's a symmetric graph. So we're going to graph that point also. So there is our upward facing parabola. We were also asked for our increasing intervals and our decreasing intervals. So remember, increasing is when you look left to right and it's going uphill, which is this. So your increasing interval is from 1 to infinity. And then your decreasing interval is when you look left to right and it's going downhill. So that's negative infinity to 1. Remember, intervals on which it is increasing and decreasing is always using parentheses, no brackets. Okay, so graph using transformations. This is just saying don't forget you know how to graph. These are all quadratic, so I'm going to graph the parent first. Remember what the parent looks like. I'm glad that I'm not reteaching that because you know it already, all right? And I'm going to use my good old, that's not beautiful, but I'm going to copy and paste that on these graphs right here. Good. And good. Okay. So this first one right here, I have a vertical stretch of a 2 on that. So I am going to write a rule for this. So remember, to write a rule for this, I'm going to say what's happening to the x values and what's happening to the y values. So for my x values, nothing's happening inside the parent. So it's just x. And then for the y values, it's 2 times that. So my point of 0, 0 is staying at 0, 0. But then when I plug in 1, 1, I get 1, 2 this time. And I get negative 1, 2. So if you look here, this graph is narrower than my original. My rule for my next one, as a reminder, using transformations here, if you look inside the parent, nothing's happening against, that's x. And then for my y values, I'm taking the opposite of the y value and adding 1. So 0, 0 becomes 0, 1. 1, 1 becomes 1, 0. Or sorry, 1, 1 becomes 1, 0. And I said it right. And then negative 1, 1 becomes negative 1, 0. So that is my downward facing parabola. That's moved up 1 from 0, 0. Lastly, my rule on this one, inside I am going to subtract 2 from x, and then outside I'm going to subtract 3 from y. So 0, 0 becomes negative 2, negative 3. Right there. And then 1, 1 becomes negative 1, negative 2. And negative 1, 1 becomes negative 3, negative 2. And then you have this upward facing parabola that looks like so. So there's us graphing using transformations. Notice we're able to do that. All right, lastly, what we have here is write the quadratic function in vertex form. Identify the vertex, the x-intercepts, and the y-intercept. Okay, so this is practice on completing the square, and then finding all of those, everything else. So if it is factorable, then I will put it in intercept form too to find the x-intercepts. It just makes life easier. But if not, I will set it equal to 0 and solve and do the quadratic formula. Okay, so put quadratic into vertex form. So I'm going to complete the square. I'm gonna do it the first way I showed you. So instead of finding the vertex first, I'm going to complete the square. So I'm gonna do f of x equals, I'm gonna complete the square for x squared plus 4x. Remember the lead coefficient has to be a 1, which it is. So I'm gonna complete this square right here. And it's instead of subtracting 3 from both sides, because I would just have to move it back over, I'm just going to scooch it over. So I'm gonna do plus 3 and pretend it's not there for a second. Now I'll complete this square for x. I'm gonna take half of 4, which is 2, and square it, which is 4. So I'll add 4 right here. And now I would usually add 4 to the other side to complete the square, but I don't wanna put anything over there. So instead I'm gonna subtract 4 from this side so it's balancing it instead. Factor that, so I have f of x equals x plus 2 quantity squared, 3 and negative 4 is minus 1. So that's vertex form, right? Now I want to know what the vertex is. The vertex is -2, -1. The y-intercept is 0, comma, look at your standard form, that's 3. Your x-intercepts you get by setting the function equal to 0 and solve. So I'm hoping for it to be factorable because that's just the easiest. But if not, then I'm gonna have to use quadratic formula or completing the square to get the answer, okay? All right, so x-intercepts, I'm gonna set the function equal to 0 and solve. So I have 0 equals, I'm gonna see if that's factorable. It is x plus 3 times x plus 1. So I get x equals -3 and x equals -1. So x-intercepts are -3, 0 and -1, 0. That one wasn't that bad. I've seen much worse. All right, next one, I want to get it in vertex form first per the directions. So I have g of x equals, I have -x squared plus 6x, leave a space to complete the square, and then I'm going to move that -4 over. But the problem is I can't complete the square yet. I can't complete the square because the lead coefficient is not 1. So in order to do this, I'm gonna have to do g of x equals, I'm gonna have to factor a -1 out of those two terms. So I'm gonna do -1 times, oh, I gotta do it out of all 3 terms if I'm gonna do it. I can't just pick 2 that I wanted. Actually, I could pick 2 that I wanna do it out of. X squared, because I'm gonna close the parentheses on it like that, right? So now let's keep the -4 out of it. X squared minus 6x, leave a space to complete the square. Do I have to factor it out of all of them? No, I don't. Okay, I was just thinking about whether or not I have to do it to the other one, but I don't, because if I factored out of that, then I would have to move it over after, no, I don't want to. Whew, I had to think through that one. Okay, so now I'm gonna complete the square for x. I'm gonna take half of b, which is -3, and square it, which is 9. So I'm gonna do a plus 9 here. And now by putting a 9 there, I didn't add 9 to this side. I added -9 to this side, right? I added -9 to this side. So I would usually subtract 9 from the other side, but I'm not gonna do that. I'm gonna add 9 to this side. So I didn't add 18 to this side, I added 0 to this side. A little confusing, yes, but that's what happens when you factor out a negative. All right, factor g of x equals negative or -1, and then this is x minus 3 quantity squared plus 5. Okay, so now I need my vertex. My vertex is 3, 5. My y-intercept, I'm gonna use standard form there. It's 0, -4. Okay. Ooh, I don't like how that looks, but it's okay. Ooh, okay. And then, oh, C, D, here we go, 0, -4. And then for my x-intercepts, I'm going to set this equal to 0 and solve. I'm going to look to see if it's factorable. do I know two numbers that multiply to give me -4 and add to give me 6, or sorry, +4 and add to give me 6, because this is -1 times -4, and the answer is no. So I have a choice. I can use quadratic formula, or I can complete the square. I already completed this. Actually, do I want to complete the square, or do I want to use quadratic? I'll do both. You know, it is a notes. You get to choose, and I want to be able to see both, right? So let's do quadratic formula first. So I'm going to do opposite of b, which is -6, plus or minus the square root of b squared, minus 4 times a, which is -1, times c, which is -4, all over 2 times a, which is -1. So that gives me, instead of 0 equals, I'm going to do x equals, because I set the function equal to 0 and solve, right? X equals, that's -6 plus or minus the square root of 36 minus 16, right? 36, no, minus 4 times a times c. 36 minus 16, all over -2, which is x equals -6 plus or minus root 20, all over -2, which is -6 plus or minus 2 root, 4 goes in there 5 times, 2 root 5 all over -2, and then I can divide both of these by -2. So I have x equals 3 plus or minus, because plus or minus divided by -2, or sorry, plus or minus 2 divided by -2 is 1, right? Plus or minus 1, so just root 5. So 3 plus or minus root 5. All right, now I'm going to complete the square to see that I get the same answer, okay? So if you're like, no, I just want to use quadratic formula, then pay no attention to me. All right, so I have 0 equals -x squared plus 6x minus 4. Okay, so let's complete the square for x. I'm going to start by dividing everything by -1. So I have 0 equals x squared minus 6x plus 4. And then now I'm going to complete the square for x. So I'm going to subtract 4 from both sides. I got -4 is equal to x squared minus 6x. Complete the square for x. That is -3 squared, which is 9. What I do to one side, I have to do to the other. So I have 5 equals x minus 3 quantity squared, and now square root to solve. So I guess I could have just used my vertex form, but I like to make things harder apparently. So now I have x minus 3 is equal to plus or minus root 5, and then add 3 to both sides. X equals 3 plus or minus root 5. So I got the same answer either way, yay. So my x-intercepts are 3 plus root 5 comma 0, and 3 minus root 5 comma 0, which you could write 3 plus or minus root 5, but I want to make sure that you see that it's 2 zeros there. Okay, sorry, it's 2 x-intercepts, which is the same thing as 2 zeros. All right, last one here. Ooh, I got not a lot of room. Okay, so I want to put this in vertex form. So I have h of x equals, in order to complete the square for x, it has to have a lead coefficient of 1, right? And this has a lead coefficient of 2. So I am going to have to factor that 2 out. So I'm going to do 2x squared, 2 times x squared plus 4x, and then I'll complete the square for x, and then I'm just going to move the 7 over. When that negative was there, I was like hurting my brain, but it's fine. You're just moving it over. It's not inside anymore, so I don't have to factor a 2 out of that. Take half of b, which is 2, and square it, which is plus 4, okay? Now, I didn't just add 4 to this side, I added 8 to this side, because 2 times 4 is 8. So I need to balance it by subtracting 8 from this side. So now I have h of x equals 2 times this factors to x plus 2 quantities squared, and 7 and -8 is minus 1. So now for my vertex, I have -2, -1. My y-intercept is 0, 7. I just look at the c value. That makes life easier. And then now I need to see if this is factorable, which it is not. So I'm going to, because I don't know two numbers that multiply to give me 14 and add to give me 8. Instead of using quadratic formula, I'm just going to complete the square because I'm going to complete it starting here, all right? Or I'll set that equal to 0 and solve. Silly, silly me, right? So add 1 to both sides. Divide by 2. Square root plus or minus. So that is plus or minus. The square root of 1 is 1. The square root of root 2 is root 2, and I have to rationalize that. So I have plus or minus 2 root 2. Sorry, root 2 over 2 equals x plus 2, and then subtract 2 from both sides. So I have x equals negative 2 plus or minus root 2 over 2. Okay, so my x-intercepts are negative 2 plus or minus root 2 over 2, comma, 0. So you can write them separate or you can write them together. All right, that's it for today's notes. Why don't you go try some practice yourself?